Hi, welcome to our subject, Highway and Railroad Engineering. And for today, we will be starting off with our discussion for midterms, which is road vehicle performance. Okay, so before we can really design our roadways or highways, we need to understand how our vehicles are performing or how the forces applied on the road are being considered for the geometric design of our highways. Okay, so for this session, we intend to discuss the following. So, a simple introduction to road vehicle performance, and we will try to discuss what is tractive effort and also what is vehicle resistances. Okay, so learning outcome natin are to introduce yung basic principle of road vehicle performance and to differentiate the different vehicle resistances muna existing on a moving vehicle. Okay? So to start, so let's have the definition for road vehicle performance. So the performance of road vehicles forms the basis for highway design guidelines and traffic analysis. Kasi nga, um, it plays a major consideration in the selection and design of traffic control devices. So, um, since our vehicle is the one always using these facilities, so yung mismong performance niya while ginagamit yung mga facilities na to are expected na alam natin kung paano siya nagwo-work para mas malaman natin what to consider sa design, what specific speed limits yung kailangan natin i-assign dun sa isang area. Let's say, maximum of 60 kilometers per hour lang at this segment. Okay? And how does the timing and control of traffic signal systems differ from each intersection? Kasi it depends on the movement ng vehicle, ng traffic. So if it's a very congested area, more or less, there is a set interval for each direction na nakabase dun sa time when the traffic is overflowing and then syempre dun sa yun nga, volume ng vehicle passing through that particular intersection. Okay? So all of those consideration before you can really design it, you need to understand what are the forces acted or acting on our vehicle. Okay? So what is the function of knowing this particular topic? One of its function is to provide insight into highway design and traffic operations, as I've said earlier, no? Um, mas maintindihan kasi natin why sometimes kailangan magkameron ng kurbada dun sa area, okay? Why do we need to have an elevated portion dun sa isang area ng road when we know the mechanics behind dun sa performance ng vehicle natin. Okay? It also forms a basis from which the impact of advancing vehicle technologies on existing highway design guidelines can be assessed. Okay? So, um, yun nga, nag-aano din siya, nakakatulong din siya for us to determine what are the improvements na kailangan pang um, kailangan pang gawin ng mga manufacturer ng vehicle. Kasi, 'di ba kayo nagtataka bakit every now and then may nagbabago yung series ng mga vehicles natin, yung brand, ano, may mga bago ng bago. So kasi continuous yung pag-develop ng mga manufacturer on how our vehicle will be more efficient, more reliable, para mas maganda yung maging performance niya when it comes to delivering services katulad nga nung exchange ng goods, ano. So that is part of the reason why we need to understand this topic. Okay? So for this topic, yung primary focus natin will be yung straight line performance ng vehicle, which will include yung acceleration, o yung pagbilis niya, kung kailan kailangan siya mag-decelerate, meaning, um, di ba, mapapansin nyo pag halimbawa nasa expressway tayo going to Manila, usually ang minimum speed should be 60 kilometers per hour and then 100 kilometers per hour um, for vehicles, small vehicles. Okay? So, bakit nagkakameron ng ganunong changes of limitations of speed? So, uh, yan ay pag-aaralan natin after nitong sa vehicle performance muna. Okay? Then yung top speed o paano natin sinaset na dapat ito lang yung limit niya or bakit kapag halimbawa once we are trying to pass through dun sa mga ramp natin, kailangan mas mabagal lang siya kasi may tendency na tumilapon yung sasakyan natin. So that is one way of showing na these signages na in-include sa constructed roadways natin are there because of the previous performances and also based from the studies na uh, ginawa dun sa mga vehicle passing through those type uh, of roadways. Okay? And then, yung ability nung sasakyan natin to ascend yung grades or mga elevated portion. Okay? So, roadway design factors has two broad classification. Ano? So we have the vehicle capabilities and human capabilities. So ito yung nakaka-affect yung variable natin. For vehicle capabilities, so syempre yung acceleration, deceleration na kayang gawin ng vehicle natin, the braking, o ibig sabihin, when we see something or obstruction ahead of us, dapat yung vehicle natin are able to stop at the time na pinrest natin yung brake. Okay? Cornering. So, kailangan meron siyang sufficient na ability to withstand yung inertia, no? Once na nag-turn siya sa mga corners or sa left or right lanes. Okay? And then we have yung human capabilities o yung perception reaction times and eyesight natin. Kasi as users ng mga vehicle na to, we are a variable talaga. Kasi kung hindi natin na-perceive na malapit na tayong mabangga, we will not be able to take actions dun sa vehicle natin kasi si vehicle natin is dependent on the input of its user. Kaya si tayo as user of this vehicle should know or should be aware on when to apply brake if ever there is an obstruction ahead of us. So kailangan or maybe later in this course, pag-aaralan natin yan, yung um, s- mga stopping site distances, passing site distances. So we will go deeper into that later. Okay? So performance of road vehicles forms the basis for roadway design, such as, yun nga, yung length of acceleration, deceleration lanes. Okay? So why do you think na after halimbawa sa expressway after having a 100 kilometer per hour the limit, once na pumunta ka na sa NAIEX, nagiging na siyang 40 kilometers per hour lang. Okay? So, what what causes those changes? Okay? Maximum grade. So, syempre, hindi naman di pwedeng sobrang tarik ng mga ano natin, ng um, mga kalsada natin. So, meron lang maximum na allotted na elevation or grade yung mismo ano natin, roadways natin. Stopping site distances, yan nga, yung passing site distances, then setting yung speed limits, okay? And then timing of signalized intersections, okay? So, to better understand or uh, before calculating or studying these guidelines, no, yung mga kailangan nating alamin for our highway, we need to understand first the forces acting on our vehicle. Okay, and it can be categorized into two group. We have the tractive effort and resistance. So for this lesson or module, we will just focus on resistances first. Okay, then we will um, discuss next time tractive effort. So let us try to define tractive effort first. So tractive effort, also referred as thrust, is simply the force available at the roadway surface to perform work and expressed in pounds or newtons. So it is a force. So it is the pulling or pushing capability ng locomotive natin. O, ibig sabihin nung vehicle natin in general kasi it is a powered equipment. So yun yung capability niya, pulling or pushing capability niya. Okay? And next meeting, we will discuss two type of tractive effort. We have yung maximum tractive effort, okay? Or yung and the engine generated tractive effort. So since we are being powered by an engine, we can really calculate how much is the capacity of our vehicle when it comes to its pulling or pushing capability. Okay? And then we also have what we call vehicle resistance. Okay? So vehicle resistance is the force impeding the vehicle's motion. So when we say impeding, they are the ones who delay, prevent, um, counteract, or make our vehicle slower. It is the force that resists the motion of our vehicle when it is moving, and it is also expressed in pounds or resist or in newtons, or it is a force also. Okay, so in vehicle performance, we have three major sources of vehicle resistance. We have the aerodynamic resistance, the rolling resistance, and the grade or gravitational resistance. So this will be our scope for this lessons for today's lesson. So differentiate these three and to understand the different formulas being used on these vehicle resistances. Okay, so let us before diving into the detail of this vehicle resistances, let us try to look at the different forces acting on our vehicle. So we have here our vehicle. So um, assuming na it's traveling at a certain grade na theta, okay, and then we have here the weight of our vehicle. And then as you can see, there are two directions ng mga forces. We have forces going to the inclined going down, right? Which are considered as our resistance. And then because they oppose yung motion natin, yung motion ng vehicle natin, syempre, papunta siya doon. So, yung lahat ng nag-oppose dun sa motion ng vehicle natin, those are our resistances or yung vehicle resistances natin. Now we have the aerodynamic resistance, then we have our rolling resistance for the front tires, rolling resistance for the rear tires, and we have um, the inertia of our vehicle. Okay? Also, we have yung grade resistance. So, the grade resistance will be discussed later. It is a function of the component ng weight natin. Okay? So, it is a function of the weight. So, it is based from the the normal force and normal force na nakikreate. So, parang sa friction din. Parang yung sa value ng friction na may coefficient of friction multiplied by the the force acting normal dun sa surface natin or dun sa road surface natin. Okay? So, that is our resistances. And then for our tractive effort o yung nagpo-push or yung nag-identify ng capability of our locomotive to to perform work or to ascend dun sa motion natin, we have FF o yung ating tractive effort dun sa front tires natin, and then we have the tractive effort dun sa rear tires natin. Okay? So when we look at this diagram, um, it is easily noticeable na yung axis natin can be oriented, ano? Ah, reoriented into the inclined, ano? Ibig sabihin, meron tayong inclination na theta g. And to solve for the forces, we can apply the to the summation of forces along the x-axis. So we consider this as our x-axis to get a relationship between the tractive effort and yung mga vehicle resistances natin. Okay? So looking at the figure, assuming that we take going to the downward direction as positive, we have so we have RA, yung aerodynamic resistance. We have RRLF, or yung rolling resistance of our front tires. Then we have for the rear tires. And then we have yung for the grade. Okay. Then we also have the inertia, or yung mass times acceleration. And then on the other side, or negative na, is yung motion natin, yung tractive effort natin, which are FR, or yung FF for the front tires, and FR for the rear tires. Okay? Then, since these rear tires and front tires are working together, we can combine yung mga resistances on each wheel. Okay? So, ibig sabihin, yung dalawa, pwede natin tawaging rolling resistance na lang. And then, these two, tawagin na lang natin siyang yung tractive effort natin. So, simplifying this formula, we have F is equals to yung ating moment, yung ating inertia, plus the aerodynamic force, plus our rolling resistance, plus our grade resistance. So, this is the main formula for our vehicle performance. Okay, so that is just the the summation of the forces along the x-axis. Okay, so each component or each item dito sa formula natin, may kanya-kanyang formula or ways on how to calculate that. So let us try now to differentiate or to discuss the different resistances. So let us first focus on these three: the aerodynamic resistance, yung rolling resistance natin, and also our grade resistance. So starting off with aerodynamic resistance. So ano daw ba yan? So si aerodynamic resistance is the force exerted by air friction dun sa motion ng body natin. Kasi as siguro naman, I assume almost everyone has experienced already pagsakay ng sasakyan, no? Or even jeepneys, tricycle. May nafe-feel tayong no, against na hangin na tumatama sa atin. Okay? And that air causes or cause our vehicle to slow down. Okay? Kasi opposing siya ng motion natin eh. So, since meron kang opposed na motion, kailangan siya, no? I-counteract siya ng ating locomotive o yung mismong engine natin. Kaya ang in return, nagre-require ng mas kailangan natin, kung ikaw yung nagda-drive ng sasakyan, na-accelerate natin, which causes greater fuel consumption. Kaya mahalaga, or if you are um, involved dun sa design ng mga vehicle, you need to understand the mechanics kapag pinag-uusapan sa aerodynamics. Okay? So, ano daw ba yung mga sources ng aerodynamic resistance? So, we have three sources. Number one, we have turbulent flow of air around the vehicle body. So, usually ito daw yung nag-account sa 85% ng total aerodynamic resistance. Okay? So, this is a function of the shape of the vehicle. Particularly nung rear portion daw, which has been shown to be the major source of air turbulence natin. Kasi once the air passes through the front, nag-aano siya, no? Nag move siya, ayan, sideways and going back. And eventually, magbabalik siya dun, ano, sa atin. So, kaya feel mo, parang ang hangin-hangin. Kaya pag bukas ang bintana, tapos you are traveling at a very um, fast way, papansin mo, gulo-gulo yung buhok mo kasi sobrang lakas ng hangin. And you can feel na your car is not performing at its optimum best, ano, or kailangan mong, yun nga, mag-accelerator, re-accelerate siya para mas bumilis yung takbo mo. Okay? Next, we have friction of the air passing through. So yan. So since si aerodynamic resistance nga is air friction, this accounts for 12% ng total aerodynamic resistance natin yung friction. And then, airflow through the vehicle components. So, syempre, tumatama siya dun sa iba't ibang parts nung body ng vehicle natin, sa windshield, sa uh, side natin, sa doors, okay? And then dun sa rear natin, si airflow also account a portion of the aerodynamic resistance, which is all equal to 3%. Okay? So, to get the formula for aerodynamic resistance, ito daw yung gagamitin. We have RA is equals to rho, or yung nakikita nyong parang letter P, over 2 times CD times AF times velocity squared. So, si RA is yung ating aerodynamic resistance. So, since that is in force, kung dapat masanay na tayo sa between English and ano, no, English units and metric units, ano. Ito English 'yan. So pwede din siya maging Newton, ano, for metric. Okay? For air density. So baka ngayon lang 'to maririnig. So we have slugs per cubic feet. Okay? So sa metric, anong equivalent niyan? Ang formula kasi ni density, kapag pumunta na kayo sa geotechnical or sa fluids na subject nyo, formula niya is mass over volume. So si volume, we are aware na yan na cubic feet yan, ano? So meaning, si slugs is a unit of mass. Okay? Ano ba ang mass kapag sa SI o sa metric natin? Okay? Lagay natin dito sa side. Pag sa metric ang pinag-uusapan natin and then mass ang ating concern, usually ang unit natin sa kanya ay kilograms. Okay? In kilograms. So, mas madaling intindihin kasi alam natin mass yan, ano? Sa English, iba yung case niyan, ano? So, si density daw is equal sa slugs per cubic feet. Okay? Pero ano ba ang mass sa sa English? That is equivalent to sa ating um, pound force. Okay? That is yung weight natin. Lagay natin dito. Saan ba natin lalagay? So, we have weight is equals to mass times gravity. Diba? Kung si weight dito sa metric natin is equals to mass times gravity, ginagawa natin that is kilogram multiplied by our gravitational constant, which is 9.81 meter per second square. So yung nagiging unit natin is 9.81 kilogram meter per second square, na ang tawag natin sa kilogram meter per second square is Newton. Okay? That is in Newton. Dito sa English system natin, ganun din. So, yung pound kasi is a force, or dapat pound force yung tawag sa kanya. May F siya dun sa subscript. Okay? Pero minsan, pound lang sinasabi natin, di ba? And then, we have M times, yung gravity natin sa English system is 32.2 feet per second square. So, ibig sabihin, yung value ng mass is pound force all over feet per second square, or pound force second square all over feet. Okay? So, pag nilagay natin dito sa formula natin ng density, okay, yung value na yun, we have pound force second square over feet. Yan yung ating mass over feet cube. Okay? Ibig sabihin, yung one slug natin is equal sa pound force second squared over foot. Okay? So, yun yung ibig sabihin niya. Yun yung equivalent niyang unit sa kanya. Okay? So, when we have then slugs, dapat automatic, maisip nyo, siya ay pound squared, uh, pound force s squared over feet, over foot. Okay? Then, kung sa English, kung sa metric tayo, so yung slugs per cubic feet ay para sa English, sa metric, ang tawag sa kanya is kilogram per cubic meter. Okay? Coefficient of drag is unitless. Then yung frontal area natin, so yung frontal area, yung AF natin. So approximately, yan yung ano natin. Halimbawa, we have a car, no? Halimbawa, ito yung car natin. Okay. Yan. Okay. So yung frontal area natin is kung ano man yung width ng vehicle natin and yung kanyang height. Okay? So approximately yung AF natin is equal sa width times yung height ng mismong vehicle natin. Okay? Ayan. So that is in feet square, or in metric, siya ay meter square. Okay? Then we have yung speed ng vehicle in feet per second or meter per second para sa metric. Okay? And yung mga ganitong problem sa resistances, vehicle resistances, most of them are just direct substitution din, ano, dun sa formula natin. So, minsan, babalik-balik na rin lang yung given, pero some of them has constant values na. Let's say, for example, itong si air density, tsaka si coefficient of drag, merong mga references for those values, like this one, ano? So, if ever hindi given sa problem, you can refer to this one. Ano ba sinabi sa problem na meron tayong 5,000 feet na altitude. So, you can use yung air density na ito as your value. Okay? So, ayan yung mga typical values ng air density if hindi siya given sa problem. No? And ito naman yung para sa drag coefficients natin. So, depende sa type of vehicle. We have automobile, bus, tractor, trailer, or motorcycle. So, it depends dun sa value ng ating mismong type ng vehicle. And as you can see, as the um, papansin mo, may mga ranges ng values. Bakit may mas mataas? Bakit may mas maliit? Kasi it depends dun sa mga frontal area din ng mismong ano natin, vehicle natin. So, siguro to demonstrate yung ano niya, no? So, as you can see, we can refer dito sa mga drag coefficient ng sum of automobiles na lumabas before, ano? Makikita nyo, yung Corvette before, 0.5 yung drag coefficient niya. Okay? Pero habang nag-i-improve yung technology natin, napapansin mo, ano ba yung smallest dito? Ito, I think si 25, ano? So, mapapansin mo nung, ayan, no? Pagdating ng 2000, 0.25, half yung nagagawa, no? So, half na lang yung drag coefficient natin. Meaning, at habang nagde-develop ng bagong editions yung mga manufacturer ng cars natin, they also consider yung kung paano mapapaliit yung mga resistance o yung pumipigil sa sa motion ng sasakyan natin kasi ang goal nila makapag-provide ng vehicle na lower ang consumption pero very good yung performance. Kaya mapapansin nyo, yung values niya, yung trend niya pababa. Pero hindi mo sila pwede compare with each other talaga na as is, ano? So, tingnan na lang natin tong example na nilagay ko yung sa Insight niya. Honda Insight, ito yung itsura niya. Okay? Then we have yung sa Dodge Ram, ito, 0.53. So, mataas, ano? Siya ata pinakamataas dito sa table na to, which is a type of truck. Mapapansin mo, yung frontal area niya, mas malaki compared doon sa Honda Insight. So, it means mas malaki yung air resistance o yung resistance, aerodynamic resistance na natatanggap ni Dodge Ram. Kaya, mapapansin mo, ano, wala mas kailangan ng mas malakas na engine. Kasi kailangan mas malaki yung kailangan mong ano mas malaki yung kailangan mong i-counteract na force kasi mas malaki yung frontal area mo compare dito sa Honda Insight natin. Okay? So, ganun yung use din pala nung mismong size ng vehicle natin. So, it does matter kung baga do sa overall performance ng vehicle natin, um, nagma-matter pala talaga kung gaano siya kalaki. Okay? And to calculate for the power na kailangan para ma-overcome natin yung aerodynamic resistance na yon, we have daw itong formulang ito. Pero saan galing yan? No? Para explain lang natin kung saan ang galing yan. Siyempre galing yan dun sa formula lang ng power. So si power, ang formula niya talaga is work over time. Okay? And si work, ang formula ni work is force times displacement. Okay? Over time. And then, kung babalikan nyo yung mga prior knowledge natin, displacement over time is velocity. So we have force times velocity. Okay? So, from this equation, yung force natin, pwede natin i-refer as yung ating aerodynamic resistance, which is identified natin yan na force. Okay? So, RA times yung velocity natin. So, let's substitute yung value ni RA. That is rho over 2 CD AF V squared. And then, multiply daw natin ng another V. Okay? So, we have rho over 2 CD AF V cube. Okay? Pero saan galing yung 1,100? Naka-2 lang naman dito. Yung unit natin dito is HP. Okay? Ano ba ibig sabihin ng HP? Horsepower. Ang 1 horsepower is equivalent to 550 pound-foot per second. So ano ba ang unit ngayon? Itong current na formula natin. Anong unit niya? So ang unit na pag-uusapan, so we have yung slugs natin. So ilagay natin yung equivalent ng slugs. So pound force second square over feet. Yan yung slugs over 2. Si CD is unitless, so wala yon. Si AF is feet square. Si velocity ngayon is, since naka-cube yun, feet cube over second cube. Okay? So, looking at this value, so magka-cancel out yung tatlo. We have, ano pa? So, we have velocity AF feet. Okay, so feet per second cube. So AFCD rho. This is feet cube. Yan, kaya pala nawawala. Okay, feet, and then that is pound per second square per foot per feet cube. Kasi yun ay um, yung ating P, ano? Yung ating density, di ba, ay slugs per cubic feet. So that is pound second square over feet. Then yung slugs over feet cube. Okay? Over feet cube. Okay? So magka-cancel out tong feet cube natin. And then may matitirang isang feet. Ang natirang unit natin is pound force feet per second. Okay? So kung naka-gano'n na siya, kung ko-convert natin to HP, okay? So, yung matitira is um, may 2 pa sa ilalim, ano? So, 1/2 nung P, C, D, A, F, V cube na ang unit is in pound feet per second. So, para mag-cancel out, para maging HP, that is 1 HP all over 550 pound force feet per second. Okay? So, ka-cancel out 'to, magka-cancel out yung unit ng, itong unit na 'to 'no? And then, this will be now P C D A F V cube all over 1,100 which is in horsepower na siya, okay? Ayan. So, yan yung conversion kung paano nakuha 'tong value na 'to based from the concept ng formula ng power. And then, uh, I just shown you yung, kung paano nag-arrive sa pound force feet per second and then convert it into horsepower. Okay? Ayan. So, yan yung sa aerodynamic resistance natin. Yan yung power na kailangan. So, ibig sabihin, pag nalaman natin yung value ng ating aerodynamic resistance, ngayon, alam na natin yung kailangang power ng engine natin para ma-resist yun. Okay? And papansin mo doon sa formula, naka-cube yung mismong velocity natin. So, ibig sabihin, pag bumilis o nag-increase tayo ng velocity, nag nag-aano siya 'no, nagti-triple, nag-aano siya, exponential yung kanyang increase ano. So, ibig sabihin, 'pag mas mabilis, mas malaking power yung kailangan natin para dun sa ano natin, sa sasakyan natin. Kaya yung mga trucks, usually mga engine niya mas malaki ano, wala kang makikitang truck na 1.0 or kung meron ka mang makita, hindi niya kaya yung mga o hirap siya 'pag yung mga mabibilis ang takbo, okey? Kaya usually mga 3.0 kaya yung fuel consumption niya is different din sa mga sedan lang, okey? At sa sedan puwede yung mga 1.0 kasi they do not require or yung resistance na kailangan nilang, i-oppose is not that high compared dun sa mga ino-oppose nung sa trucks, okey? So ayan, so yun yung sa aerodynamic resistance natin. Now we go sa rolling resistance. Okay? Rolling resistance naman daw refers to the resistance generated from the vehicle's internal mechanical friction and pneumatic tires and their interaction with the roadway surface. So, yung mismong contact ng mismong gulong natin with our road surface, nagke-create siya ng resistance. So, yung internal mechanics niya o yung yun nga, yung dun sa mismong tires natin. Kaya papansin niyo dun sa analogy natin kanina, we have different value o forces dun sa front tires natin. Okay? Meron tayong sariling resistance si front tires, then meron din si rear tires. So we just combined it here para kasi ina-assume natin na equal yung performance nung front and rear tires natin. Okay? So sa rolling resistance, meron din siya mga sources. Okay? So ang number one sources niya is yung deformation ng tire natin. So nag-account yun sa 90% daw ng rolling resistance natin. Siyempre, ano, kasi sabi nga, di ba, yung car natin, parang meron na siya more or less 3 to 5 years. Kailangan palitan mo siya ng sasakyan, sorry, ng gulong. Or kapag expired na yung gulong, yung date dun sa gulong natin sa tires, we need to um, change yung tires natin kasi yung mismong material natin is nag-deteriorate yung kanyang capacity o yung carrying capacity niya, no? So sa deformation, yun, kung mas ano na siya, nasa end na siya ng life niya, mas madali na siya mag-deform. So mas nahihirapan yung sasakyan. Okay? Penetration and compression, that is 4%. So, syempre kung mas malalim o baku-baku yung daan, syempre yung rolling resistance natin is greater kasi kailangan mag-exert ng mas mataas na force para i-resist yung mga challenges na yun dun sa surface ng roadway natin. And then we have frictional motion or circulation ng air. So, account yun sa 6% naman ng total resistance din. Okay? So, yung frictional motion daw, due yan dun sa slippage ng tire dun sa roadway natin and sa circulation daw nung air around dun sa tire. Kasi nga, syempre exposed din yun. Hindi naman natatakluban yun ng ating, ano, no, yung mismong harap nung sasakyan natin. Hindi naman niya natatakluban entirely kasi sa sides, nagpa-pass through din ng air. So, meron siyang tinatawag na fanning effect. So, that is 6% nung source ng rolling resistance natin. And may mga factors na nakaka-affect sa rolling resistance natin. We have three. Yung tire rigidity and roadway surface. So, itong dalawang to, um, nakaka-influence sila dun sa degree ng pag-penetrate ng car natin, nung tires natin dun sa road surface, yung compression and deformation ng tire natin. So, depende sa type ng surface natin, whether we have a hard, smooth, or dry roadway, um, magpo-provide siya ng lowest rolling resistance kung wala masyadong, kung, kung smoothly yung ano natin, kung wala masyadong nag-oppose dun sa motion natin. Okay? For tire conditions, ibig sabihin kasama dito yung kung ilang pressure yung nasa loob ng mismong tires natin. So, let's say, ano ba, meron kang kinargang kung maliliit lang sa sasakyan, ano, di ba, mga 36 PSI lang yung pressure niya. Okay? And kapag mas mataas daw yung pressure, nagde-decrease daw yung rolling resistance sa hard paved surfaces natin. Okay? Pero nag-i-increase yung rolling resistance kapag malambot or unpaved surfaces tayo. No? Kumbaga, nasa ano tayo, na magraba tayong lugar. Okay? Kasi kailangan ng additional effort para yung mag-adjust o gumalaw yung mismong vehicle natin. Then last, we have vehicles operating speed. So, increasing yung speed results in additional tire flexing and vibration. Kasi syempre, yung mismong engine natin, pag inano natin yung accelerator natin, ang tendency niya is to rotate faster. So, yung tires natin are being directed to roll faster. So, kung mas faster yung rolling ng tires, may additional um, effects yan doon sa ating operation o dun sa mismong speed ng vehicle natin. Okay? So may formula din sa rolling resistance. We have yung formula ng RRL or ng rolling resistance is equals dun daw sa um, formulang 'to. Pero itong formulang 'to is a simplification na 'no, kasi there are, wide range of factors na nagde-determine talaga ng rolling resistance ng isang sasakyan, and you cannot really, pinpoint a general formula for each type of vehicle. Pero for computation's sake, ito yung simplification na ginagamit ng textbooks 'no. So we have here na yung overall rolling resistance daw natin can be, approximated gamit yung product daw nung friction term, ito yun ano, yung coefficient natin, yung F, and then nung weight ng vehicle acting normal dun sa road surface natin. So, kanina, di ba, meron tayong road, yung road natin naka-incline. Ito yung ating, bawa, yan yung ating car. Okay? Yung weight niyan, syempre, nasa center niya, ito yon, no? Ang sinasabi niya dito na yung weight normal to the road surface, ito yung surface natin. Pag sinabing normal, naka 90 degrees sa kanya. Eh si weight natin, kailangan kunin natin yung component niya. Ito yung weight natin. So may component niya na going dito sa direction na to and going dito sa direction na to. Okay? So kung ito ay angle theta, ito is also angle theta. So para makuha to, we have yung tinatawag nating, para tayong may nafo-form na right triangle, and kapag may right triangle, ano yung karaniwang inaano natin? Yung trigonometric function natin, which is yung SOHCAHTOA, no? I-side note lang natin dito. SOHCAHTOA. Ano ba ibig sabihin ng SOHCAHTOA? So, we have sine of an angle is equals to opposite over hypotenuse. Okay? We have cosine of an angle. We have equals to adjacent over hypotenuse. And we have tangent of an angle is equals to opposite over adjacent. Okay? So, ano yung reference niyan? Halimbawa daw ito yung right triangle mo. Okay? Then ito yung angle mo. So, yung opposite niya, yung nasa tapat, adjacent niya is yung leg na kadikit niya, and then yung longest side is yung ating hypotenuse. So, ito yan. Same lang din yan. Ano? Kung ito yung angle natin, itong side na to is yung adjacent niya. Ito yung kanyang, itong force na to, parehas lang yan ito, no? Parallel siya doon. So, ito yung kanyang opposite. Tawagin natin yan, since meron tayo kaninang axis, okay? May axis tayo na, ito yung x, ito yung y. So, let's call this as wy, and then this is wx. Okay? Ang kailangan natin is yung normal sa surface natin. So, ito yung kailangan natin, wy. And according dito sa figure, wy is, ito yung given natin weight. So, that is adjacent tsaka hypotenuse. So, alin ang adjacent at hypotenuse? Adjacent tsaka hypotenuse. So, cosine theta yung gagamitin natin. So, for cosine theta is equals to wy all over w. O yung wy natin is equals to yan sa w cosine of theta. Kaya meron tayong cosine theta dito sa formulang to. Okay? So meaning, itong whole expression na to dito, ito yung ating friction, yung coefficient of friction natin na tinatawag. Coefficient of friction, of rolling resistance na lang, of rolling resistance. Okay? So unitless yan. Okay, yan, yan. Unitless yan. Then ito yung ating weight ng vehicle acting normal to the road surface, excuse me. So, dito, ano bang angle natin? So, sa mga most highway applications, yung theta, yung value ng inclination natin is quite small. Okay? So, kung small siya, we can assume na yung cosine theta natin is equals to 1. Kaya papansin mo doon sa final equation natin, naging times W na lang siya. Okay? So, inassume na yung cosine theta dito ay equal sa 1 due to very small values ng angle kapag inaano natin. Kasi hindi naman pwedeng sobrang tarik nung ano natin, ng roadway natin, ano? Kaya, ayun. Then, kung meron tayong force, pwede natin makalculate din yung kanyang power. So, same formula ulit nung kanina. Power is equals to force times velocity. Kaya, yung formula natin, so that is um, 1 plus V over 147 times W. Ito yung ating force, okay? Multiplied by yung ating velocity. And then, yung magiging unit niyan is naka, ano na naman siya, no? Pound. May 0.01 pala dito sa okay? Naka-pound feet per second yan. Okay? Tapos may 0.01 dito. So, para maging horsepower, mamultiply natin ng 550 HP is equals to 1 pound. And baliktad. So, 1 HP, 1 HP, 550 pound feet per second. Okay? So, magka-cancel out yung unit. Okay? So, sabihin 0.01 divide 550, that is 55,000. Kaya meron tayong 1 plus B over 147 times WV all over 55,000. Yan yung power natin kapag sa rolling resistance. Yan yung required power para ma-overcome natin yung rolling resistance natin. Okay? So, ayan. So, paano natin ma-appreciate to? So, before we go dun sa grade resistance natin, let us try to solve an example problem for aerodynamic and for um, rolling resistance. Okay? So, let's have this problem. A 2,500-pound car is driven at sea level with density of 0.002378 slugs per cubic feet on a level paved surface. The car has a coefficient of drag na 0.38 and a frontal area of 20 feet square. It is known that at maximum speed, 50 horsepower is being expended to overcome rolling and aerodynamic resistance. Okay? So, determines the car's maximum velocity. Okay. So, dito, hindi in-specify kung may ibang value, no? So, yung sa equation natin, yung horsepower daw natin, yung power na meron tayo, nakadepend lang daw siya dun sa overcome yung rolling tsaka yung aerodynamic resistance. So, yung capacity and power niya is equals to power sa aerodynamic force and power sa rolling resistance. Okay? So, after nyan, pinapanos natin yung V. So, ano bang formula ni PRA? PRA is yung mula dun sa discussion natin ng power for aerodynamic, that is equivalent to PCDAFB cube over 1,1. Okay? So, let's rewrite. That is PCDAFB cube over 1,100. Okay? Plus yung rolling natin. So, yung rolling resistance based from our previous slide is this formula. Okay? So, 1 plus V over 147 WV all over 55,000. Okay? Um, ito ay yung P na natin. Gawin na natin to yung P natin. Na equivalent daw yung P natin sa 50 horsepower. Okay? So, we need to simplify itong equation natin. So, multiply natin both side by 55,000. Okay? So, 55,000 times 50. So, i-distribute natin. So, 50 times 55,000. Okay. Then we have 55,000 divide 1,000, 11,000 or 1100s. That is 50. P, C, D, A, F, V cube plus 1 plus V over 147 WV. So, ito, simplify natin. 50 times 55,000, that is 2.75 times 10 to the 6 or 2.75 million equals to 50 times yung ating number, 0.002378 times yung area na daw natin na 20 V cube plus 1 plus V over 147. W natin is 2,500 times velocity. Okay? Simplify. 2.75 times 10 to the 6 is equals to 50 times 0.002378 times 20. That is 2.378. May kulang dito, no? EQ. Okay. So, 50.002378 times 20. Yung CD, no? Nalimutan ko i-substitute yung CD. So, bago mag-frontal area, dapat ay may CD. 0.38. Okay? So, that is 0.904 V cube. Then, ito is i-distribute natin. So, plus 25 V plus 25 divide 147. That is 17 V squared. So, we have a cubic equation. So, may cubic. Let's try to rearrange. V cube plus 17V squared plus 2,500 V minus 2.75 times 10 to the 6 is equals to 0. So, to solve for V, you can use shift solve if you have sa calculators nyo. Or, we can also use yung function ng calcu. Kasi, pag cubic equation na, minsan, numerical solution na, wala pa kayong subject na gano'n. Kaya, let's stick with the solution sa calcu. Okay? Sa calcu, you can use mode 5 and then 4. Yung 4 yung cubic kasi yun yung may 3, ano? So, nakalagay doon, lalagay mo lang yung coefficients ng equation mo. So, sa una, yung 0.904, pangalawa, 17, and then 2,500 minus 2,750,000. Ayan. Then, enter. You will have a value for V is equals to 132.818. Ang unit niya is feet per second. Okay? So, yan yung unang value ng X, yung iba imaginary na. So, ibig sabihin walang ibang value kundi yun lang, ano? Kasi dapat may tatlong root ka. Okay? So, let's go back dun sa ating slide. Okay, ayan. So, ito yung na-calculate natin using calculator. Okay. Feet per second kung yan yung nakalagay sa question. Pero pwede ding iba. Halimbawa, pinahanap is ang unit dapat is in miles per hour. So, ilan ba ang miles per hour ng conversion ng dalawa, no? Nung feet per second tsaka yung miles per hour. So, that is, let's check. 2 miles per hour. Okay. So, ang conversion, 1 miles per hour is equals to 1.47 feet per second. Okay? So, kung gusto natin gawing miles per hour, so 132.818 feet per second. So, para maalis yung feet per second, lalagay natin sa ilalim yung may feet per second. And then sa taas yung 1 mile per hour. Okay? Cancel, cancel. So, we have V is equals to 132.818 divide 1.47. So, we have 90.35 miles per hour or roughly 90 mph. Okay? So, yan yung speed ni car. Okay? So, based lang sa formula ni power for aerodynamic resistance and power based sa rolling resistance, we were able to arrive with the unknown velocity ng car. Okay? Okay. Next, we have yung last is yung grade resistance natin. So sa grade resistance, madali lang. Siya lang yung gravitational force o yung component parallel dun sa acting dun sa vehicle natin. So nakita natin kanina dito sa derivation natin, yung Wy, yun yung ginamit natin dito sa rolling resistance. So yung Wx hindi pa natin nagamit. Okay? And si Wx, according dito sa figure natin, ito yung angle, ito yung Wx that is opposite tsaka hypotenuse. So, sine tayo. So, Wx is equals to, or sine theta is equals to Wx over W or Wx is equals to W sine theta. Okay? Kaya, yung W sine theta na yan yung gagamitin natin dun sa grade ano natin. Okay? Ayan. So, equal lang doon yung ating grade resistance. W sine theta. Which is roughly, since maliit nga lang din yung angle natin, equal din daw sa tangent over theta, theta angle natin. Okay? Bakit nilagay doon? Kasi doon sa grade natin. Okay? Copy ko lang to. Okay? Ayan yung ating figure. So, yung sine theta natin roughly equal daw sa tangent theta. And as we can see dito, pag tangent theta, tangent is opposite over hypotenuse, ano? So, ayan. So, roughly equal um, to G. Okay? Kung ano yung nakukuha natin G. And G is yung tawag natin sa grade. Ang grade is yung vertical rise per some specific distance. So, kung ano yung rise natin, 10 over 100, yan yung ating um, grade or in terms ng percentage, times lang natin ng 100. So, kaya 10% to. Okay? So, again, grade is vertical rise per distance. So, kung halimbawa ito yung ating angle, kung ilan yung dimension nitong vertical over yung horizontal niya, yun yung grade natin. yung mismong run natin. Okay? So with that, let's have um, an example. Okay? So a 2-pound car, siguro, no? A 2-pound car has a drag coefficient of 0.4, frontal area of 20 feet square, and available tractive effort of 255. If the car is traveling at an elevation of 5,000 feet, so given yung elevation, so ito daw yung density yung gagamitin natin on a paved surface at a speed of 70 miles per hour, what is the maximum grade that this car should ascend and still maintain 70 miles per hour? Okay. So, ano daw yung grade na kailangan natin? So, ilang percent ng inclination ngayon yung hinahanap natin. Okay? So, dito, to maintain yung speed natin, walang ibang sinabi dun sa problem, no? So, to maintain yung mismong speed natin, dapat yung tractive effort natin na given o yung F natin should be equal lang dun sa ating naka-present na forces. So, meron tayong aerodynamic force plus yung sa ating rolling resistance plus yung atin sa um, grade. Okay? So, wala nung due to mass time acceleration kasi um, ano lang, maintain lang yung ating yung ito no, maintain lang yung speed natin. So there is no change in motion, no change in velocity. Kung walang change ng velocity, wala tayong acceleration. So wala tayong inertia. Okay? O yung MA. Wala tayo ng MA. So kakalculate natin ngayon to. Given yung tractive effort na 255, so F is 255. So isahin natin si RA muna. RA is 1/2 of P rho over 2 CD AF V squared. Okay? So yung rho natin is equal to 0.002045 over 2. Drag coefficient is 0.4 times yung ating conversion, ano? Naka 70 miles per hour. Pero nung kanina, ang required natin for velocity, dapat naka feet per second siya. So, may conversion tayo kanina na how much ngayon? We have 1 miles per hour is 1.47 feet per second. Feet per second. Okay? So, yung 70 miles, para maging feet per second, so 1 mph is equals to 1.47 feet per second. Okay? Cancel yung miles per hour. So 70 times 1.47. Okay? That is equivalent to 102.9 feet per second. Okay? So 102.9 feet per second squared. So yung RA natin will be 0.002045 divide 2 times 0.4 times 102.9 squared. That is equals to 0.4. Wala yung frontal area, no? Nalimutan ko ulit. So, let's include yung frontal area natin. Okay. Frontal area is 20. Okay. So, this is equal to 86.61 pound. Okay. Next is RRL. Okay. RRL natin is equals sa ating coefficient of rolling resistance times yung W natin. So yung weight daw ng car natin. So we have 0.01 times 1 plus yung formula natin for um, is V over 147 times W. Okay, so we have 0.01 times 1 plus yung velocity natin 102.9, 147 times 2,500. Okay, so 0.01 times 1 plus 102.9 all over 147 times 2,500. So we have 42.5 pounds RRL. Okay? So meron na tayo meron tayong given nito, may given tayo nito. So RG na lang ang wala. Ang RG natin according to our formula is equal sa WG o yung weight tsaka yung grade natin which is unknown. So equal yan sa 25 pounds G. Okay? So substituting all values dun sa equation natin. Let me rewrite lang this. Okay? So F is equals to RA plus RRL plus RG. So that is 255 is equals to 86.61 plus 42.5 plus 25G. So yung G natin is 255, transpose lang natin, 86.61 minus 42.5 divided by 2,500. So that is 0.0504 or gagawin natin percentage times 100. So kailangan natin ng 5.04 degrees na grade para ma-maintain yung speed natin. So ibig sabihin, yung elevation ng roadway natin, okay, para hindi dapat siyang 5.04 yung inclination niya. Yun yung ibig sabihin niya doon. Okay? So ito yung sagot na natin for this problem. Okay? So yan yung para sa vehicle resistances natin. Next time or next meeting, we will try to go deeper dun sa tractive effort. Okay? And then after discussing tractive effort, we will combine everything, si tractive effort and si vehicle resistances. And then we will try to discuss yung tinatawag nating braking or stopping distance natin, yung braking distance. Okay? So that's it for today. Thank you for watching the video. See you guys next video.